Hello friends, once again welcome in a second video of one-dimensional motion, displacement, velocity and acceleration. I am Assistant Professor Swapnil Sampatrao Shenge, Head Department of Physics, KANMS, ACS College, Satana. So in earlier video we have discussed one-dimensional motion, displacement, velocity, and now we are going to discuss the acceleration. As we all know, acceleration is nothing but the rate of change of velocity. So here is a constant acceleration, and it means the rate of change of velocity is constant. So dv by dt is equal to a equal to constant. The solution of this equation is v equal to v naught plus a t. So v is nothing but here final velocity, v naught is nothing but initial velocity, a is acceleration, and t is time. Distance move at constant acceleration. At constant acceleration, dx by dt, here t is gone some lower side, so we can understand it. So dx by dt is equal to v of t is equal to v naught plus at. So as I mentioned that v of t is nothing but a final velocity, v naught is a initial velocity, a is acceleration, t is time. The solution of this equation is given as x of t. That means x means it is a displacement. So x of t is equal to x naught plus v naught of t plus 1 half at square. So here x naught is the beginning position, that means initial displacement, v naught is the beginning velocity, a is the constant acceleration here. Okay. More about constant acceleration. In this graph, the graph of velocity as function of time. So v of t is equal to v naught plus at is a straight lines. Here in this graph, x-axis indicates the time taken to travel, and y-axis indicates the velocity. That means here indicating that v naught is nothing but an initial velocity, v1 is the final velocity, and we have to start with initial velocity and reach up to the final velocity in time 0 to t1. Okay, so by connecting these points, there is a point and line is a straight line. That means the acceleration continuously or constantly increase, there is no variation in acceleration. If v equal to v naught and t equal to 0 and v equal to v1 at t equal to t1, the average velocity over the time interval 0 to t1 is v bar equal to v naught plus v1 upon 2. Okay, but remember that this formula is unlikely to be correct at non-constant acceleration. If acceleration is constant, this formula is not applicable for that. Okay, here is some formula, that is constant acceleration formula, are very well known as kinematical equations. Okay, so here v equal to v naught plus at, in which v is final velocity, v naught is initial velocity, a is acceleration, t is time. Here again x is equal to x naught plus v t naught plus 1 half at square. Okay, so here x is final displacement, x naught is a initial displacement, v is velocity, t naught is nothing but initial time, 1 half is multiplied, a is acceleration, and t is time. Again another formula, that is kinematical equation, v bar is equal to v naught plus v1 divided by 2. So v naught again here initial velocity, v1 is final velocity, and we get the velocity. V square is equal to v naught square plus twice a x minus x naught. This is the last kinematical equation. Here v square is the final velocity square. Here v naught is initial velocity, a is acceleration, x is displacement and x naught is a initial displacement. If we are rearranging all these formulas, we get the initial velocity, we get the final velocity, we get the time, we get the acceleration, and we get displacement also. It is totally depending upon that whether which quantities are given in the problem. Okay, so ask problem have such a quantity, and if we remember these formulas, then it is easy to solve or easy to find out the absent quantities which are not given in that formula. Okay, so these are the kinematical equation and which are mostly useful in our physics. So these are the references which are used to create this video. Thank you, friends. Thank you.